So this is a more recent version of the same plot. I think there's now order 800 supernova observations here. You can see again, everything still lies really, really nicely on this line, relating how bright our supernova are to how red the light from them is looking. And again, maybe you can convince yourself that there's a slight upward curve to this line. And that is the evidence that we have that the expansion of the universe is accelerating. Now, actually, when we put this together with the other observations that we have in cosmology, it tells us that the universe actually needs two extra components that we call dark matter and dark energy. Now, dark matter is what we need to explain the rotation of galaxies, and dark energy is what we need to explain the expansion of space in between galaxies, if you like. And from putting all of the data together, that the ordinary matter, so everything we are made of, everything the planet is made of, everything the stars that we can see are made of, that they make up about 5% of the matter in the universe today. Another roughly 27% is made of this dark matter that lives in the galaxies, and then about 68% is the dark energy, so whatever is driving the accelerated expansion of the universe. So it's a big deal. It's a lot of our universe today, and we don't know what it is. So I say we don't know what it is. Actually, initially, this looked quite straightforward to explain. So we said that gravity likes to pull things together, and that's why we expected the expansion of the universe to be slowing down instead of speeding up. But actually, there is an extra term that we can add into the Einstein equations. And again, I'm not going to go through the maths, but this is just a point. This is a term that you can or can choose not to have in these equations. And there's been a bit of a debate about whether it should be there or not. But if it's there, it can cause the expansion of the universe to accelerate. So perfect, job done. What was all the fuss about? All we need to do is go out and measure how fast the universe is accelerating. That tells us the value of this constant, and we're done. The reason that's not the end of the talk is because gravity isn't the only thing that we have to worry about in cosmology. But the other thing we have to worry about in cosmology and fundamental physics is quantum mechanics.